Hello, so today I'm going to be showing you the PicoScope 2200 entry-level USB scopes. So these are a low-cost USB oscilloscope. You can see I've got the PicoScope website open. So the model I'm going to be showing you is actually this $160 one without probes, but you can add probes if you want. And the range actually goes up to 200 megahertz analog bandwidth and 1 gigasample per second. So if you're looking at one, just a quick note, check the specs carefully, because what you might find out is probably if you're looking for budget, but you can afford about $500, you can get this 50 megahertz analog bandwidth, but it has some additional features. So you're talking 500 megasample per second sample rate, so very high sample rate. If you look at the specs, you notice, for example, the scopes are basically split into two versions. The 2206A is the lowest cost of the second version, which includes the ability to have analog offset ranges. And it also has more samples, so 32 kilosamples. It's still quite a small sample memory, but faster streaming, and your waveform generator is also quite a bit faster, so it can generate up to 1 megahertz waveform. The two lower cost models only give you up to 100 kilohertz. So that sort of could be, 1 megahertz is good enough to be fairly useful for a lot of stuff. If you're only doing audio, of course, 100 kilohertz would be fine. And note the sample rate too. It generates 100 kilohertz. It is still a 2 megasample per second update rate. This one's 20 megasamples per second. So one thing you'll notice with PicoScope compared to a lot of other low cost ones is they don't really skimp on the ratio of the analog to digital or digital to analog rate compared to the analog bandwidth. So for example, at 10 megahertz analog bandwidth, we're still sampling at 100 megasamples per second. A lot of people will sell you a scope that's 50 megahertz analog bandwidth at that sample rate, but you're going to find some artifacts from that, because there's still going to be stuff that leaks into your ADC, and so you're going to see sort of some weird effects. So PicoScope's quite conservative on that side. And I'll show you some real examples of that to give you a better idea of what the 10 megahertz bandwidth looks like. So let's connect to live. So this is the scope here. I've got some targets around and some other stuff in the way. So it's quite a small little device. I've got a little bit of Velcro on it because I actually just stick it under my desk and keep it plugged in all the time. And it's great for travel. It's actually made in the UK too. So the PicoScope, when you're comparing it to a lot of the low-cost ones on eBay, you'll be pretty surprised that this whole thing's made in the UK. $460, and we'll take a look inside it in just 1 second. One other cool thing about the small size is that if you have something like a tablet, so here I have a Windows 8 tablet. Obviously it has to be Windows 8 based. It can't be Windows RT or whatever. We can plug it in. And let's see if you can see this properly. So it'll actually run the PicoScope right from this. So we now have a nice little portable platform. Let's turn the screen brightness down, maybe. Nice little portable platform, and you can use the whole interface by touch even if you want. So you just take the keyboard off, and you've got a little portable scope. So that's pretty cool. But mostly just because it's so small and portable. But what is inside this? So if you're curious, how do these compare? Let's take a look here. Stuff away. So the PicoScope, you can open it up. The outside is actually recyclable, interestingly enough, whatever 7 is. And we have a shield. So this is sort of metallized plastic there. And there's the main PicoScope board. So you can take this out. So this main chip, we have an FPGA, Spartan 3 FPGA. We have a Cypress Easy USB interface, so that's, you can see, connected right to the FPGA. And there's no external memory chip, so all of the memory is actually probably the block RAM inside that or other RAM. And there's nothing on the back side either. So the really important thing to realize, and what sort of differentiates something like the PicoScope from other low-cost scopes is you can confirm that the analog, the ADC, is actually spec'd for 100 megasamples per second. So they're not oversampling anything. You will find, or overclocking, I guess I should say. So you will find that some of the low-cost scopes sometimes take parts and they just use them beyond their range because they figure, well, they're spec'd to 100 megasamples per second over the entire temperature range. If you're using it at room temperature, then whatever, it'll probably still work. So they're not pushing the bounds. So you should expect to see somewhat better analog performance. We do have the analog. So this is the signal conditioning, and when you're adjusting, the ranges will be done through all this stuff. We have some relays here for various features. So relays for coupling, changing coupling modes, and probably might be 1 or 2 for changing levels. And this chain here is the output, so the analog output here. So it's generating the signal there, gain some conditioning and whatnot. So that's the board. So let's go ahead and put this back together, figure out roughly how it went. Well, we'll just fire it in here for now. Yeah, looks about right. All right, and now let's take a look at the software side. Actually, before I show you the software, one other interesting thing to point out. So the probes that come with it, one over from my test platform here. So this is the probe that comes with it. They're PicoTech branded probes. I don't know who the original manufacturer is, but they are in fact different. So when you buy these Chinese scopes, you almost always get, there's this one type of probe that always seems to come with them, and they're all over AliExpress and eBay and whatnot. And they're not a terrible probe, but they're not the highest quality. And you can notice, for example, even the Pico ones, the wire feels thicker in the Pico ones. And interestingly, in this cheap one, the alligator clip is crimped. So this isn't a real crimp, of course. This is what's supposed to be the insulation shield. I don't know if you can see that, but what they've done is they've just taken the wire and bent it backwards behind what should be the strain relief and crimped it in there. So I don't think it's gonna have great high frequency response, or it may not last too long if this stuff oxidizes. The Pico one is sort of more what you'd expect, soldered right there. So it's soldered to this, and then this is just used as a strain relief. So just sort of a small indicator maybe of the quality difference. Again, these are low-cost probes, but it's nice that they're at least reasonable seeming. All right, so let's go ahead. So let's look at the software. So this is the PicoTech software here. So this is the same software that all their scopes use. So the cool thing is that if you have this $160 scope or you have a $7,000 scope, it's the same software. So they're also putting a lot of effort into the software. So let's put a high frequency signal here. And so we have a 10 times probe set up. And I'll start with a 3.6 megahertz clock. Let's get a trigger somewhere and start drilling down. So there we can see. So the square wave actually looks quite good, especially for only officially 10 megahertz analog bandwidth. And I can go up to say a 7.37 megahertz, and we still get a fair amount of detail. So it's actually fairly impressive. Very cool. But there's a lot more to it. So let's look at an analog waveform. So I'll actually plug this into so I've put my scope tip into the arbitrary waveform generator output. So we can see, for example, 1 kilohertz. So remember, this is limited to, 100 kilohertz, I think, yeah. So there's a square wave. And it looks like it can't quite generate the resolution we need there. Okay, that's a little better. Let's make this easier. Let's put a 20 kilohertz square There we go. So you can see the analog side here too. So a cool thing, you can use equivalent time sampling. If the waveform is very repeatable and reliable, you can actually use this to achieve about 2 gigasamples in this module mode sample rate. So I don't, in this case, the sine wave coming from the AWG, I don't know if it would be reliable enough for it to work. But otherwise, you start to see this type of sort of the lines going up and down, indicating it's sort of unsure of what the value should be. So there you go, half reasonable, but it is kind of a useful feature. Swap around. So other cool things you get, of course, the other features that are in the main software, such as this persistence mode, so you can see where the signal sort of is laying over time. So you can switch around here and you see what happens. So you can see it gives you sort of this color map. Kind of cool. And you have the FFT mode, of course. So again, we can play with that. And you get up to 10 megahertz. So it's fairly useful for probably a lot of stuff you're going to do. Of course, you are limited. So let me connect my clock back here. There's a 3.6 megahertz. So the one thing is, because you're only 8 kilosamples per second, you're limited in the resolution. So I can set it to 8,000 bins, and it doesn't matter if I go higher because it only has so many samples per capture. So there you go. And you can see I have a Circuit Seller article talking a bit about some of these features. All right, so let's look at other stuff. So some of the other cool features of the whole PicoScope system are its ability to do serial protocol decoding. So if you're doing digital work, this is really handy. So let me connect up a serial line here. And we trigger on, say, falling edge. There you go. So you can see some serial data. So again, because you have this 8 kilosample limit, you may find that you can't quite hold everything in. And let's set this to only run on a trigger. So there's a serial data stream. Oops, too short. So there's a whole serial data stream. So if you go serial decoding, and you have a whole bunch of serial protocols, so you can use a UART, and it picked up automatically what it thought it was, so you can see all of the UART bytes. So that's pretty handy, and you get stats on when each byte happened in the system, and you can view additional information if you want, voltages, how you want to decode it. So in this case, it's ASCII. So that's actually quite a handy feature, and you could of course do this on both channels at once if you wanted. So hopefully this video gave you a bit of an overview of the PicoScope 2200 series. As I mentioned at the beginning, you can look through the specs for the different models, and you can also check out, I have a Circuit Seller article talking about some of these features in the selecting of a USB scope. So the other useful thing with the 2200 series is you can drive it from an API. So they give you a great API. And there's some examples, C, C++. And I have this Python library, actually, that myself and another guy, Mark, have been working on. And it's on GitHub if you want it. But you can, for example, I'll run this demo. And it drives both the arbitrary waveform generator and gets samples. So if you want to use the PicoScope in any sort of laboratory applications, this is obviously super handy because you can just script everything. So here I'm just generating a waveform and capturing it, but with this mode you get a lot of control over the hardware. You can even stream data in. So I think someone has an example where they use a PicoScope to decode a composite video signal in real time. So there's a lot you can do with these. You basically get to use the PicoScope as your own analog front end to do whatever work you want. So that's another advantage of this, and I guess any of the PicoScope devices, but over some of the no-name ones that don't have nice APIs. So hopefully this was a useful video to demo a little bit of the PicoScope 2200. And so check out the video description for a link to the Circuit Seller articles too. But I hope this was useful, and let me know if you have any questions. Thanks.